Hi, welcome back to my channel. My name's Alex, aka Polymonster, and I'm just going to do a little thing talking about Rust today, and a little situation that I ended up getting into working on my graphics engine Hotline, and it's an issue that crops up fairly frequently and takes me off guard, and then it also takes a little while to fix it. So I was just going to talk about that, show some examples of how to fix it, because in encountering this problem, I found some patterns to use to fix it, but it still catches me out unexpectedly. So the problem is this error. So I cannot borrow view as immutable because it is also borrowed as mutable. And I can show you how the code worked and then began to start failing working. Okay, so in this little setup, I've managed to isolate it and just break down what was happening. And in hindsight, it becomes more obvious, but also, I don't know, hopefully it makes sense. So we have a type called a command buffer. We have a parameter. It doesn't really matter. It's just something we need. And we have on a command buffer some methods we can call that are like do something. So we do something and it takes a self. Okay, this is how the code base was working. So command buffer, you would do, I don't know, fn draw indexed, that's a command buffer thing, or so that kind of stuff. And it takes a self. And then we have a get view function, which is an arc mutex of view, because these views are passed around, ref counted. I had to use this to get it to work, to get the bug or the borrow checker thing to happen. And then we have a render function, which that gets stuff passed into it, but in essence we get the view based on a name. Actually, we then lock the view, and then we start doing stuff in the command buffer. What happened was my command buffer functions all took an immutable self. And when I was porting to macOS to Metal, the command buffer started to have to track some state in order to be able to make the direct 3D version on Windows work the same as macOS. This is common with graphics APIs. Where the calls happen or the grouping of things might change slightly. So I want to maintain my front end. I don't want to kind of refactor everything too much. So I thought, oh, I'll put some state in the command buffer. But then in doing so, I had to change this to mutable. In hindsight, a command buffer, all of these doing things like, setting or binding should be a mutable thing, really. It's just that in the original implementation, it had like, internally, this had another thing, the internal one, and it'd be ID3 D12 command list or something like that. And in command list, when you call, like self dot internal dot do something, didn't require, the mutability. So in D3D kind of drove me to design the API like that, because initially I just kind of wrapped up some of the stuff that I needed. But in hindsight, what I thought was, well, the mutability should be more explicit. So I need to make this mutable. So I'm going to do this for the entire command buffer. Everything that sets anything or uses a command buffer should be mutable, because in future platforms might need to change stuff, and they are actually mutating the command buffer. Now, there are different ways to solve this problem, but let's just look at it at first. If I try and build, I've got this problem, cannot borrow view as immutable here, because I'm also borrowing it as mutable here. Now, I think coming from sort of a C background, I'm thinking, well, this is not mutating view, it's mutating CMD, and this is taking param1 as as a parameter. It's not really to do with view. The view themselves are just a container, right? And these are separate elements, but borrow checker doesn't really understand that. So I think I run into this a lot because I use things as a view because like I just want to call get view. A view has a command buffer in it. It has information about how to render the scene from that view. But now I've got to split the data up. So there's a few ways that you could actually do that. So the way that I actually did it to fix it for my case is use take. So what we could do is we need to separate these two things. Now, mostly we would have, I could take this out, but then I would have, maybe if I've got loads of parameters, then I would have to do that for all of the parameters. So what it made sense to me was separating the command buffer from the view. So then what I had was cmd, and I use take. So we have this kind of take pattern. But the problem is that we don't have default. So this is okay if you can either derive default or you have a default. Okay, so now I do command buffer. I've separated command buffer out of my struct, and then I can return it in the end back into it. This has solved the problem. So I take the command buffer out, I've separated them, and I can pass them around. This is possible to do in other ways. You could do it by cloning as well. I can cheat here because this class is easy, right? But I could derive clone. That won't make take work. But what I can do is I can make a new cmd clone. And then I can do that. That's going to compile. So we have the first option is take. Then we have clone, which is like that. But then the problem with these things is you end up with more struct members inside. Are they clonable? Are they defaultable? And how easy is it to use in the rest of the code base? So I could make it also, I could take, if I make it an option, and you can also use swap as well. If you have another one, you could have a default or something to swap it with. It's kind of the same, but you could make it an option, and I've done that in the past. CMD becomes option because I can't make an easy default for CMD buff. If it had loads of members in here, and they all then, you need to make those clonable, you need to make those default. So instead of doing that, I can go, well, I can make an option, and an option's always going to have none as the default. So we can do that. But then the problem is you have to call asmut, unwrap, and then you have to, still put it back at the end. But what this means is that potentially, if you have to do this, like you have a mutability issue to solve, and you need to borrow and you need to separate them out, then you've got to change a lot of places in the code. So because now this is option, if I have functions, elsewhere, other functions using it, then I've got to change those. So it is preferable if you can derive a default, or if you have a default, or it is preferable if you can derive a clone, because it just means you don't have to change as much of your code base. So another option is that you can do ref cell. So this changes view to a ref cell. And then you have to do borrow mut, which gives you a ref mut, and then you can deref the ref mut, and then we're good to still call that. So if we have the working take example again, and we consider that we have some other function, this just works, basically. We have to add that code. If this goes back to being immutable, right, so we're back to kind of the start where both of the functions in the command buffer do something and do something else. They don't take mutability, or they don't have any mutability issues. I come along to do something and I'm like, this needs to be mutable now. Okay, we can't borrow as a mutable, so I do the take mechanism. Cool. We can take, and now we can separate the mutability, and then it's still fine. And we have another function which does something else. That's great. Okay, that's working. Say if I consider now making this ref cell, I update this mechanism to do view cmd borrow mut off ref cell, and dereference it to set the value. So now we're like, cool, we fixed the call site where we had our mutability problem, but now we've got some other functions that need to be changed. So changing to ref cell introduces that same kind of problem. A very more heavy-handed way you can do it, you could do an arc. So if you're doing multi-threaded arc mutex, and then that will allow you to lock, unwrap that, call a do something function, and pass the thing. Putting things inside atomic reference count or reference count also will allow them to be clonable. So if you're having trouble to make something clone, you could separate the mutability by doing a clone on this as well, but you would still have to do lock, unwrap, and call do something. You still end up with the problem where your other function is still not going to compile, because now you need to do a lock and an unwrap on there, and now it all compiles. So you can do take, clone, take and swap with an option is another way to kind of get around having a default. Ref cell or atomics reference count. Basically, I do find this a problem because this is a contrived example, but I will show you what happened in my main engine. I had it in, there's a bit more code here. Let's make this a bit bigger for the purpose of the stream. And then I just had this happening. Here's all of the errors. You've got millions of them. This is inside a macro as well. So actually at the call site, it's just like, oh, this macro is failing. And then it didn't have a default. Basically, here's where I call the take. And I was just testing this before in order to, check that it was still compiling, like to get the error to happen and then to check it out. So it was a bit of a pain because then I had to take command buff. I still have to change all of this code to change it from view command buff to the command buff that I've taken the mem off. I still had to update all of the places calling these functions, so now they get passed in a separate command buffer that is separated from the view. That needs to be carefully checked, and it was a ton of functions which I can't navigate to because Rust Analyzer is a load of garbage at times. It was still a lot of code to change. I mean, I just had to change the difference between calling view command buffer or command buffer. In some places, it was already taken into a temporary reference anyway, but all of these functions were changed. Reset, it was previously a self, it's now mutable self. Close is mutable self. Get back buffer index, that is immutable because it's a get function. It returns a U32. It's not mutating internal state. But most of these functions are like, they're doing things on the command buffer, and I've made them mutable. Now, I could have kept it the same and kept the functions the same. The other option is that you go with the interior mutability. So we can go back to the original example. These ones solve exterior mutability. Let's go back to a plain old command buff. So we're still failing because of mutability. If this compiles, okay, this is compiling now, and the API has stayed the same. We're not changing this to mutable, but the problem is that in here, I've got internal, but I can't set it, right? I can't use it. So I need to go for interior mutability because I can't change this to a mut self. So then I could go, okay, how do I deal with this? Well, this could be in a ref cell. So then internally, from the outside world, we're fine. And then from interior mutability, I can then change it. That would mean I'd change how the command buffer works inside. I think this is a bit of a toss-up between what you want to do. Now, I had this happening in another place in the code base where I needed to make the window and the app clonable. So I decided to go for them for atomic reference count because they are passed between threads, and that then they could be locked and they can be written to, and then the internal functions are allowed to mutate them. In this case, the reason I designed it this way is how the engine works. So going back to going back to here, the command buffer in the design of the engine, it gets passed into these plugin systems, and the plugin systems are, they have these export update functions, or let's see, export a render function, right? Exporting a render function. So the idea is that we pass a mutable command buffer into the function. The command buffers are allocated for each view. Each view is dispatched potentially on its own thread, but each command buffer only is written to and handled by one render function at a time. So each view has a command buffer. They're written to asynchronously, and they are dispatched in order or submitted in order in a queue for the GPU. So this is the CPU writes them asynchronously, and they're submitted in order. So the design is that the mutability there is explicit. Only one thread writes them at a time, and so they're passed into the thread. So I decided to be explicit with those mutability. I think in this case it's handy because you then know that is, it is mutating it. If you have interior mutability, you're hiding that from the user, and there might be costs involved with that. If you're using Atomic's reference count, I used it for a whole app or a whole window because we don't really use it that many times, and they're kind of large objects. Whereas a command buffer, you're going to call to it a lot of times, and repeatedly locking, unlocking mutexes for every function call seems excessive when you know you're going to unlock it. It's going to be safe to write for the entire duration of this function. So that was just for my case. Basically, this has been hopefully educational. If you encounter this problem, if you know about it or have any different opinions, let me know, because the reason I'm bringing it up is it happens to me, and then it is regardless of the solution that you choose, regardless of, if it's exterior mutability, interior mutability, it still takes time to refactor the code. And the problem isn't the call site of the code that's happening. It's all the places in the code base that haven't been affected that will now be affected with the change. And I find these things propagate quite deeply in the code base and affect things a lot more than you actually initially think they would. Certainly much more than designing APIs and building them in C++ or C. I understand the reasoning behind all of these things. It's definitely just something that catches me off guard all the time. So I'll leave it there. Hope you enjoyed it. If you do, let me know. If you learned something, also let me know. If you want to see more videos like this, then also let me know. Subscribe and comment on things, and check out all the stuff I've been working on. And I hope you have a good one. And finally, up the Rust. Yes.